Hello, this is a short review of quiz number 2 that you'll see on your flash drive. If I click on my quizzes folder and I look at the actual quiz number 2 folder, there's no MXD file associated with it. So we'll work with the quiz 2 old.pdf and I'll go through the answers. Like I've said before, you'll see some of the same questions worded differently, but this is an old quiz that I've given, so please be sure you know how to internalize the questions, how we got the answers, and how they may change. Number 1, a blank refers to an individual instance of a point, line, or polygon within a vector GIS. This is what we call a feature. Okay, one individual feature. Multiple features compose a feature class. Number 2, we have a field called population for census tracts within Durham County. What type of data is it? Typically, this is going to be ratio data. The difference between interval and ratio data is that interval data can go below 0, ratio data cannot. Population, we cannot go below 0 population. We might have pop change, we might have percent change, we might have temperature. Those can all go below 0. Population cannot. So we can set up multiplicative relationships between population fields or counties. So we can say this county is twice the population of another county or whatnot because of this relationship. Number 3, there's a field called FIPS, which is used to identify each census tract using a unique identifying number. This is what we call nominal data. Nominal data. It identifies it, like our 820 number or our social security number. I can't say my 820 number is higher or better than your 820 number. We can make comparisons between, GPA or the number of credits we've taken or even our birth date, but we can't do this with our 820 number. Number 4, which of the following types of data would best be mapped using a color ramp? The word ramp implies that we have a grade from, say, 0 from pink to dark red with grades in between those or shades of red in between those. Typically, we look at ratio data because we're looking at quantitative comparisons between data. Nominal data, definitely not. So we're looking at, say, religion or 820 numbers or the county that you were born in or whatever. We definitely would not want to have grades or color ramps between those because those lighter might imply less and darker more when in reality we don't want to make those comparisons. Number 5, a map where points are made larger based on an attribute's value. Those are what we call graduated symbol maps. Okay, choropleth, or when we color in counties, graduated symbol for points. A thematic map portrays specific information using different types of symbology. Remember, a thematic map, the whole goal of a thematic map is to show some type of variable, whether it's, crime rates, HIV/AIDS rates, ADHD rates, school achievement rates, where the biggest hurricanes or whatever. That's a thematic map. So we can use this using graduated symbols. The thicker the line means this. The larger the dot means this. The lighter the polygon means it's less for whatever variable we're looking at. Number 7, in a map, the symbols and their meanings can be found in the legend. Number 8, in making maps using color ramps, the maximum number of colors that should be used typically is about 7 to 8. After 7 to 8 colors, our eyes can't distinguish between one class and another. Number 9, the shape of the Earth is what we call an oblate spheroid. It's actually not a sphere. The equatorial circumference is a little bit longer than the polar circumference. Okay, so it makes it an oblate spheroid. A lot like, if we were standing on, say, a basketball. It's difficult to notice. We have something called flattening ratio, and it's about 1/300, meaning it's only about 0.3% difference. So we're not going to notice that with our eyes, but using the high precision and high accuracy tools that we have now, we can get this really, really close. Number 10, one popular map projection is the Mercator projection. What's the disadvantage? And we showed that in the example in class that we've showed before, is that Greenland appears to be the same size as South America and Africa, when in reality it's about 8 to 10 times smaller. So it approximates the shape of the Earth to be a cylinder. when in reality, as we go further and further north, those lines of latitude called parallels get smaller and smaller. Now there are advantages to the Mercator projection where that lines of latitude and longitude do in fact meet at right angles when projected onto a flat surface, i.e. a map. Okay, so right here, regions near the poles appear much larger than what they really are. Okay, and I've got some essay questions here. I may not have essay questions for the quiz you're taking here, but number 11, briefly explain a scenario where you would want to normalize data that's being mapped. I'll talk about a couple of examples because I may integrate that into future quizzes. One is if we're looking at, say, crime. Obviously, larger counties or counties with more population are going to have more crime than other ones because of population. So if I were to map crime by county, obviously Mecklenburg, Wake, Guilford, Forsyth County are going to have high number of crimes because there's so many people there, or deaths or whatever. So in essence, when you're mapping crime or deaths, non-normalized, you're essentially just mapping where all the people are, you know, to commit the crimes or to die or whatever. So normalized, we would want to normalize those data by population. Let's look at the number of crimes per 10,000 population. So some of the examples that I've shown in class were that if we look at violent crime rates, actually higher in rural areas when we look at the actual number of crimes per 10,000 people or per 100,000 people. Places like Wake County and Mecklenburg County aren't quite as high. Another example, if we were doing tornado maps, later in this semester we're going to map counties by the number of tornadoes that they have. Obviously larger counties like Wake County and Columbus County, since they're larger in area, are going to have the chance of having more tornadoes. States like Texas, well, they have lots of tornadoes, but when we actually look at the number of tornadoes per square mile, Oklahoma, Kansas, Florida have more tornadoes per square mile. The fact that Texas is just really, really large skews that a little bit. So normalize, you know, I use the example with the no-duh questions. You know, if we map this and see, oh, Texas is really high and these larger counties are really high, of course, no duh, because there's more people there, a larger area, or whatever we're mapping by. Number 12, name one advantage and one disadvantage of using a quantile mapping technique. Okay? From what we've talked about in Chapter 3, quantile basically means we line up each county from least to greatest, and we just take the first percentage. Now in North Carolina, it's pretty easy. We have 100 counties, so if I was doing a 5-class quantile, the first 20 would be in the first class, the next 20 would be in the second class, the next 20 would be in the next class, and the last 20 would be in the last class. So each class, each color appears the same number of times. So that would be an advantage. Each color appears the same number of times. Now, one of the disadvantages that we talk about is that these ranges, since we're typically looking at, and hopefully if we're normalizing our data, we're looking at data using a bell curve. So those data that occur at the left or to the right near the outliers, they're going to encompass a wide range of values. So they'll encompass a wide range of values. So you might have two counties that have the same color that have a wide range of values with those. Okay. Number 13, what's the goal of the North Carolina State Plane projection? The goal of the North Carolina State Plane projection is to minimize the distortion when we map the state of North Carolina. In theory, North Carolina is on it's 3D. It's got mountains and whatnot and topography, but it's also on a 3D globe. So projection was when we place that onto a flat surface. That's the whole idea of a projection. For the state of North Carolina, we talk about the parameters so that we minimize the distortion. Some of the maps that we have in our classroom have the actually north edge of North Carolina curved. Well, in reality, it's not curved, but that line of latitude is curved. So when we run from east to west, we're truly not going left and right. We're finding that line of latitude. And we take into account that small distortion so that, you know, it's the SAD principle. We're going to have to minimize the shape and azimuth and direction and, you know, conformity in order to have the best projection possible. So that's the reason why we have the North Carolina State Plane projection. Now we can show other states like New York or Idaho or whatever, and we've probably done this in class. You can show them, but they're just going to be distorted. They might be tilted or appear strange because, well, the whole goal of North Carolina State Plane is using the parameters of what we call the standard parallels and the central meridian so that we minimize distortion for the state of North Carolina. It doesn't care what New York or Idaho or California really looks like. So it'll show it, but it'll show it with distortion.